Okay, ladies, Bismillah ar-Rahman ar-Rahim. In the last lecture, we studied about linear equations, and today we will learn about linear inequalities. Inequalities are actually whenever you see in any expression, if you see such kind of signs, not equal, greater than equal, or less than equal, such kind of signs, if you see in any kind of expression, that will become inequality. Okay, some inequalities are very simple, like you have here x not equal to 10, x greater than 10, x greater than equal to 10. So such kind of inequalities are very simple. Similarly, on the other hand, you may have inequalities like that, y less than 5, okay, y greater than equal to 5. Okay, so these are also very simple inequalities. Some inequalities are mixed. Okay, mixed inequalities in which you see both variables x and y. So in this analysis, in LP analysis, you might have such kind of inequalities. Means just y only, or just x only, or you may have the mixed inequalities as well. Okay, in today's topic, in today's lecture, we will discuss about the graphs of inequalities, and if we have simultaneous linear inequalities, how to get their solution. So this is the topic of today's lecture, and we will start it with the help of one example. Let us go to the whiteboard and see how we deal with the inequalities. Suppose you have an inequality 2x plus 3y equals to 12. Okay, you have this inequality, and now you want, it is less than, okay, less than equal to 12. Okay, now if you have this kind of inequality, how to make it sketch? Okay, this is the objective of this question. Let's sketch the inequality, this one. Okay, in order to solve this kind of problem, first of all, um, we need the sketch of the corresponding equation. Okay, step one, sketch the corresponding equation. Okay, sketch the corresponding equation. The corresponding equation will be 2x plus 3y equal to 12. Okay, now, and you know from the previous lecture how to make sketch of this equation. We just need 2 points, and those 2 points you can obtain simply by having x-intercept and the y-intercept. You put x equal to 0 and you get y, and then for the other point you can put y0 to get x. Okay, so you get these 2 points. The next, you will take these 2 points on the coordinate system. You will draw the coordinate axis. Here you have x, and here you have y, and now you will scale the x. Okay, x varies from 0 to 6 and y varies from 0 to 4. So the best scaling on x-axis, and on the other side you have 0 to 4. So you can take 2, and here you have 4. Okay, the first point is here 0, 4, and the others here you have 6, 0. So the other point is here. Now what you need to do, you will just draw the straight line, and joining both the points, you will get the straight line sketch for this equation. Okay, always keep in mind that the sketch of inequality will not be a straight line. It will be an area. Okay, it will be a region. Okay, now once you draw your line always keep it remember that your area will be above the line or below the line. Okay, means the area that represents this inequality, okay, the sketch of this inequality will be either above the line or below the line. Okay, now what we need to do in take a test point. Okay, we need to take a test point. Either you have above the line or you can take any point below the line. It's up to you. Okay, you have to choose one test point on either side. Okay, suppose I take 2 2. Okay, 2 2 is here. Okay, this 2 and 2. uh, okay, we consider the point 2 2 as the test point. uh, and now we will put this point 2 2. Okay, this point 2 2 I will put now inside the inequality. Okay, you can see now, if this point satisfy that inequality, this means area below will be the true area. Okay, 2 multiplied by 2 plus 3 multiplied by 2. Okay, what do we get? 4, and here we get 6. So 4 and 6 is equal to 10. Okay, and 10 is always less than or equal to 12. So this means that the point that we took here below the line, it satisfies the inequality. So this means that the true area is the area below the line. Okay, if for example, you took the point on the above the line. Okay, suppose you took 4 4. Okay, here you took the point 4 4. When you put this point in this inequality, here you will put 4 and 4 12 and 8 20. So you will see that inequality will not satisfy. So it automatically it will indicate if the inequality doesn't satisfy, the opposite side is the true region. So we shade this region. Okay, we can say that this area is the true area for that inequality. Okay, so this is the way how we make the sketch of an inequality. This sketching technique that we adopt to sketch the inequality.
Doctor, your voice is not
Anything that
clear.
you
Your voice was cutting while you were explaining how to determine the area of the inequality. May you kindly explain that again?
Okay, sure. Okay, just wait for a few minutes. Let me check. Okay, let me explain it again. First of all, we need to make the sketch of simple linear equation, and then next is you will take one test point. Okay, the test point could be on the either side. Either you will consider this test point on area above the line, or any point at the area below the line. Okay, so I took the test point to be 2 2. Okay, 2 2 is very visibly uh, at the area below the line. So once you consider this point, you will put this point in the inequality. Okay, you will put this point in the inequality here. So once you will put this point in the inequality here 2, and in place of y2, you get here 10. So if this by putting this point, if this point satisfies the inequality, okay, because 10 is less than 12, so it satisfies the inequality. So this means that this area is the true area. Okay, you will shade the area below the line. Okay, okay. So let us take another example. we will sketch another inequality, minus x plus 3y greater than equal to 9. Okay, so let us do this one. Okay, first of all, I will I will do the step one. Step one is to convert this inequality into equation. Okay, x plus 3y equal to 9. Okay, so I converted this inequality into equation. So once you converted this inequality into equation, next step is to take 2 points. Okay, we will get 2 points from this inequality. Okay, first of all, I will put x to be 0. Okay, and y comes out to be 3.
Three.
Yes. Okay, now on for the second point, you will put y0. Okay, x will come out to be minus 9. Okay, if you put here y0, x will be minus 9. Okay, as I told you earlier that we don't want to see negative quantities. It will take our sketch in the irrelevant area. As I told you earlier, whenever we make the sketch, I told you that we want to keep our graph in the first quadrant. So this is not a good choice of the points. So what you need to do, okay, we need to rethink on these 2 points. Okay, so what could we do? Look, we take the point, if I consider the value of x. Okay, with the value of x, if I consider 3. Okay, if I consider it 3. Okay, if you put here 3 will go to that side, you will get here 12 by 3 will be 4. Okay, if we consider here 3, y will be 4. You can consider 1. Okay, you will consider here 1 as well. But what happens, you will get here a point in points, in decimals. Okay, I want to avoid decimals in these 2 points, so that our sketch is very clearly visible. We can easily plot, avoiding the points. Okay, so you have to take such a value. It's not necessary. Okay, this is not necessary step, but just to get a more accurate sketch. Okay, I want to avoid the decimals. Okay, if you consider here 1, it will be correct. You can take here 2, you can take here 3. 3 is better because you will get a whole number. Similarly, if you take here 6, 6 is also better, because if you take here 6, we will get here 5. Okay, if you take here 9, you will get here 6. So the multiple of 3 is better, because in that case, but it is not required. Okay, it is not required that you always keep here such a number that you get whole number. It is not a required thing. So it's up to you. It's up to you. If you want to keep here a whole number, so you have to accordingly select such an x, so that you get a whole y. But it's up to you. Okay, anyhow, we got 2 points. Okay, now we will move to the coordinate system. Here we have x, and here we have y, and here we have 0. And now you can see x is varying from 0 to 3. So I take here 1, 2, 3. And y is varying from 3 to 4. So I consider here 1, 2, 3, and 4. Okay, the first point is 0, 3 here. Okay, so this is the first point, 0, 3. And next point is 3 to 4. Okay, 3 and 4. So around here, we will have the second point. So once we have both the points, you will start your line from here and meeting the second point. Okay, so this is your sketch of the line. Okay, now the area of inequality, either it will be above or it should be below. Okay, it depends. So now you have to take the test point. Okay, always keep in mind that 0 0 is the best test point. Okay, 0 origin, this test point is the best one because it doesn't require any inequality. You can see here 0 0 is below the line. Okay, always keep in mind that 0 0 is the best test point. Okay, so origin, let me write here, 0 0 is best test point. Okay, but sometimes, if for example your line is crossing 0 0, okay, you should not take origin as the test point. For example, if your line is passing through the origin, then 0 0 will fall on the line. Test point should not be on the line. Okay, it should be either above the line, very visible, or below the line. It should not be on the line. Okay, now we take 0 0 as the test point. Okay, this point I'm considering as the test point. I will go now back to the original inequality. I will put here 0 plus 3 into 0. Okay, so what do we get? We get here 0. Okay, is 0 greater than or equal to 9?
No.
No. Okay, so this
No.
means that this test point fails. Okay, it has been failed. So if this point has been failed, this means the true area is the above the line. Okay, because 0 0 was below the line and it failed, it got failed. So this means that your true area is above the line. Okay, this is your true area. Okay, so this is the way how we make the sketch of inequalities. Do you have any question, anything that
No,
you are
totally.
not
Thank you,
getting?
Gab.
Okay, okay, great. This is actually the start of linear programming. If you got it, that how to make sketch of inequalities whenever we enter in linear programming, you won't have any trouble. Okay, in especially in the calculations, there will be nothing difficult for you. Okay, now we take another example. We have another inequality, x greater than equal to 5. Okay, we want to make it sketch. So what do you say about that?
It is horizontal, I mean vertical line.
Vertical line. Okay, then what happened? What will be the area?
Either right
Even
or
in the
either
right
left.
or left.
Yes, on the right or left, but which one? Right or left?
The
Only to the
right.
right.
On the right. Okay, now let us do it. um, uh, uh, X, first of all, I will convert it into the form of equation. Okay, which is the first step always. And now I will make the sketch of this, and in the previous lecture I told you that the sketch is a sketch for x equal to some constant is always a vertical line. So if we draw x and y coordinates, suppose here you have 1 2 3 4 5. So your line will be a vertical line at x equal to 5. Okay, so this is your sketch. But the true area, because it is greater than, if you put 0 0 as the test point here, so 0 will not satisfy the inequality. Okay, 0 x 0 is not satisfying the inequality. So this indicates that the true area will be on the right side here. So this is the true area we have. Okay, another one. We have another inequality, y less than 10, less than equal to 10. What do you say about that?
It's
So
in,
it's like one and it's below 10.
down. It's below.
Okay, great, great. First of all, I will write its equation. And now sketch is very simple. It's because we know from the previous lecture that any equation of such kind, y equal to a constant, it's a horizontal line. Okay, so suppose we have 10 here, and the line that we want to make it sketch is this horizontal line, and because it is less than, okay, and if I put 0 0 inside this inequality, means y0, y0 satisfies the inequality. So 0 0 is below the line, so true area is uh, below the line. Okay, so always keep in mind that I'm not going here. Okay, because in that way we will enter in the fourth quadrant. Okay, we have to avoid reaching to the negative x-axis and negative y-axis. We have to keep ourselves in the first quadrant. Also, one more thing, suppose, okay, suppose we delete this one. Okay, y is now less than 10. What happened? What happened in that case? Y less than 10?
It's still the
Same.
same, doctor, but
It
without
will be the same, but
including.
what happened? What
The
what has been?
line,
We will not
the line is
include
not included.
as
Not
a
connected
point.
line.
Okay,
Dotted
great, great.
line.
The points on the line, okay, the points on the line, they are not included now. Okay, these points which are on the line, they are not included, but the point just besides the line, okay, here they are included. Okay, just below the points below the line are included, but points on the line, they are not included in the area. Okay, so we put usually a dashed line in case of if we don't have here equality sign. So we put a dashed line to indicate that the points on the line are not included. Okay, so that's all with the sketching. Now we come to the solution technique. Okay, how to get the solutions of inequalities. um, so let us consider, we consider here uh, two inequalities. Okay, solutions of inequalities. We take some two arbitrary equations, inequalities. Suppose 2x plus 3y greater than equal to 9, or better take 12. Okay, and suppose x minus y is less than equal to 10. Less than equal to 10. Okay, or let me take less than equal to 5. Okay, yes, that's fine. Okay, now we have to get the solution of these two simultaneous linear inequalities. Okay, suppose this is 1 and this is 2. Okay, now what we need to do, first of all, we will convert both of them into the form of equations. Okay, we will calculate their corresponding equations. So first one is 2x plus 3y equal to 12, and x minus y equal to 5. Okay, we took both the corresponding equations, and from these two equations we need 2 points. Okay, first from the first one, we can simply take x-intercept and the y-intercept. If you get the y-intercept, we put x0 and y will be 4. And for the second one, if we put y0, we get x to be 6. Okay, now if we take 2 points from the second one, okay, if you put x0, y will be -5. Okay, so let me put y0 and x is 5. Okay, x is 5. And for the other one, if I put some other value, for example, if I put y to be, suppose 1. Okay, if I put y1, what will happen? X will be 6. Okay, or if I put y equal to, suppose 4, okay, x will be 9. So any value you can give to y so that you get a positive x. Okay, I want to get x to be positive, so you can give any value to y. Sorry, we give any value to y. I can give the value 4 to y, so that I get here a 9. Yes, right. Now it is fine. Okay, so we got 2 points for the second inequalities, 2 points for the first one. Okay, now the next step is we will go to the sketch. Okay, sketch of these two inequalities. I will just draw the coordinate system. Here we have x, and here we have y. Okay, now we need a scale, 0, 6, 5, 9. So maximum x will go to 9. So accordingly, I will 1, 2, 3, 4, 5, 6, 7, 8, and here we have 9. Now for y, if you see 0 to 4, maximum it is going to 0 to 4. So you can see here 1, 2, 3, and 4. Okay, now we will draw the first line. Okay, we will draw the first line. First line first. Don't mess up by putting all the points together, all 4 points. First of all, you have to plot line 1 separately. So line 1 is 0, 4, this point, and 6, 0 here, and joining both of them, okay, we get this line. This is line 1. Okay, now we will plot it sketch. Okay, for the inequality, you can see the inequality here. Okay, you can see here. Okay, the area above or below? Which one?
Above.
Above, because if I put 0, 0 as the test point in the first inequality, here I will get 0, 0. So 0 is not greater than 12. So this means the area above is the true area. Okay, area above is the true area. Okay, now we will just we shade the area above. Okay, now we will plot the second inequality. Okay, and second inequality, if you look, the first point is here. Okay, first point is here, 5, 0. Sorry, the first point is here, 5, 0, and second point is 9, 4. Okay, 9 is here and 4 is here. Yes. Okay, now meet both the points. With the help of a straight line, we join both of them. Yes, this is the second line that we have. Okay, now area to the left or
Left,
right?
left,
Left.
left.
Are you sure?
Bec-
Yes, yes, to the left, because if you put 0 0 here, it satisfies the inequality. So this point 0 0, which is on the left, it satisfies the inequality. Okay, now let us shade the true area that we have. Um, okay, so let me shade. Okay, the area to the left.
Doctor, in which axis do we measure? Like, for example, here, um, it might we might hit, for example, 6 or 7 on the y-axis on this area.
6 or 7, sorry. What
Like
you said?
now, when we plot, for example, 0 0 in the first inequality.
Yeah,
Yeah.
for the second one, same point you can take.
Yes, 0 0. We are highlighting left, right?
Yes, exactly,
Yeah.
exactly. Because if you see, if you extend the line, if you extend this line, okay, here it will go down. So you can see the this point 0 0 will be on the left side. Okay, this point 0 0 is on the left side, and right side is here. Okay, so you can say above, this one you can say above, or this one you can say below, or you can say left or right. Okay, it's up to you, it's up to you how you interpret. Okay.
Doctor, the left is the below, right?
Left is, it's above. Okay, left side, it's up to you. Look, it doesn't matter, left, right, above or down, it doesn't matter. Okay, how do you interpret, how, where do you see 0 0, on this side or that side? Okay, so 0 0 is on the left side, you can say, because this line is slightly, it has a larger slope, so you can say left or right. If it
Okay.
has very small slope, you can say above or down. Okay, like in the previous line, I wrote above or down, you can say this side is left, or this side is right. Okay, it's up to you actually, it doesn't matter, it doesn't matter, left, right, or above,
And
down.
yeah. And doctor, and we measure the value according to which axis, the y-axis or the x-axis?
uh, y-axis, or what, 0 0 0 0 mean both of them. Okay,
Yes, I
this
mean,
one.
like for example, now here in the second equation, okay, we filled 0 0, 0 in place of x and 0 in place of y, and
Yeah,
both of
yes,
them they are smaller and than 5.
yes,
Okay,
yes.
yes. And now, do I find the 5 on which axis, like on the y-axis or on the x-axis? Because if I was measuring, for example, on the y-axis, then the highlighted area will even include the which is larger than 5 on the y-axis.
No, you are actually, look, you are actually interpreting it wrongly. Look, we put here 0, okay, and we put here 0, and
Okay.
because it is equal to 0 and 0 is less than 5, so we check that this inequality is true if we consider any point on this side, it means on the left side of the line. If we consider any point, this inequality will satisfy. Okay, this inequality
Okay.
will satisfy for all points in this area. Okay, all points in this area, if we choose any one, for example, if I choose uh, 3 4, okay, 3 4, if I choose this point, okay, 3 4, you put this point in this inequality, you will see that that point will satisfy the that inequality. Okay, so that's why we will shade all the area on the left side.
Okay. Thank you, doctor.
Okay, now you can see now. Okay, look at the change of the color. Okay, actually green color when I selected for the first inequality, I didn't this area as well, because the whole shaded area is on the right side. Okay, so this all area was the plot of the first inequality. Okay, so this whole area was the area for the first inequality. Okay, and for the second one, we have the pink one. Okay, where both of them mix. Okay, the common area.
The
Okay, the
darker
common
one.
area is the black one. Okay, the common area is the black area. So we can say from here we can say that the solution of the inequality, okay, solution of both of them will be this one, this area. Okay, starting this one, and so on. Okay, so all this area that is common between first and the second inequality will be the solution. So this whole area is the solution of these two inequalities.
So then do I choose, for example, a point from this area and I designate it as a solution, or I just simply end my
We stop here. We stop here. This is the solution. Okay, all actually inequalities have infinite many solutions. Okay, the solutions of inequalities could be infinite many. So all points in this area are the solution. They will satisfy both the inequalities. Okay, this means that if you choose if you choose any point in this area, any point in this area will satisfy both the inequalities. Okay, so that's why this is called the solution. Okay, now uh, we go to the slides, and we take some examples from there. uh, yes, come to here. In this example, uh, this example will lead us to the linear programming as well. Okay, look, in LP, always the step one is to translate your real world problem into mathematical language. Okay, that mathematical language is called inequalities. Okay, by reading this statement, we have to construct inequalities. Okay, we will not enter in the linear programming. We will just model and make the sketch of inequalities. I will tell you in the next lecture that what is LP. Okay, what is LP? I will tell you in the next lecture. But in today's lecture, just learn how to model inequalities. Okay, now we consider here if a farmer, he wants to use 2 brands of fertilizer for his corn crop. Okay, always keep in mind that whenever we start linear programming, a linear programming problem starts with two types of two types of something. Okay, two types of brands, two outlets, two factories. Okay, such type of, always you will see in LP there are two types of some things. Okay, these two types will be the variables x and y. Okay, usually in the first statement you will see the variables, you will identify the variables. Okay, now what are those two brands? The first one is brand A. Okay, brand A, you can say that this is X. It contains 26% nitrogen and 3% phosphate. Okay, this is the information for X. X requires 26% nitrogen, 3% phosphate. Brand B, which is Y, okay, you can say that this is Y. It contains 16% nitrogen and 8% phosphate. Okay, this is the information, same information for B. Okay, look at, read this sentence. Okay, the first part of the question is, uh, how many pounds of each brand of fertilizer should he add to each acre? This is the unit of the area. if he wants to add at least 120 pounds of nitrogen. Okay, there will be a keyword. Okay, there will be a keyword that will lead you to the sign of the inequality. Either it is less than equal or greater than equal. It You will get this thing by the keyword hidden in the question statement. Okay, so if you see here, at
At
least,
least.
Greater
if
than
you,
or equal.
Equal or greater than.
yes, great. So greater than or equal. Okay, so this means that how many pounds of each brand of fertilizer should he add to each acre if he wants to add at least 120 pounds of nitrogen. So the condition on the nitrogen, okay, always keep in mind the shape, the generalized shape of inequality will be this one: ax plus by, okay, either less than equal or greater than equal to c. Okay, so c is very clear. It will be 120, at least 120. Okay, and sign is very clear from here. Okay, rest of these two things, x you know, y you know. Okay, so for nitrogen we have to construct an inequality, uh, which for which you know that it is 120, and you know this thing, and you know x, and plus always, okay, plus, and here you will have y. Okay, these two things you need to identify. Okay, x contains how much nitrogen?
26.
26%. Okay, so I will write here 26%. And y requires how much?
16.
16%. So I will write here 16. Okay, so this is the nitrogen constraint we have. If you want to write it without percentages, you can write 0.26 x plus 0.16 y greater than equal to 120. Okay, that's all with the first part of the question. In the second part, how many pounds of each brand of fertilizer should be added to each acre if he wants to add at most at most at most
Less than or equal.
yes, less than equal 28 pounds of phosphate. So the restriction on the phosphate is we cannot consume more than 28 pounds. So C we know, okay, it is 28. And the sign we know that it is less than, and we know X and we know Y. Okay, so on the phosphate, X requires phosphate of 3%. Okay, so 3%, and Y requires the phosphate 8%. So 8%. And now without percentage, if you want to write, it will be 0.03x plus 0.08y less than equal to 28. Now this is called the model. This is called the mathematical model of the of this situation. Now we have to make the sketch of this model. We will take these two equations on the whiteboard and we will try to solve. Okay.
Doctor, I have one question.
Yeah, go ahead.
Under what condition we decide that this one is X and this one is Y? If I convert it, it will give me the same solution?
Okay, look, with practice. Okay, you will learn this thing with practice. This is very hard thing, by the way. Identifying the variables from the question, it is very hard. Okay, it is not it's not very simple thing that you immediately read the first statement and you will identify. Usually in common, okay, whenever in the first statement it is said that two types of that, or two outlets, two brands, two products. Okay, so they are X and Y. Okay, but sometimes if the question shape is different, okay, they start this first statement with some other information.
So we are
Okay,
taking the simple part. We just
Yes.
consider that the first one will be X, the second one will be Y.
Yeah, look, I will tell you. Okay, once we will enter in the linear programming, I will tell you some techniques. Okay, some formulas, how you would know that which one is x and which one is y. Okay, actually, till now we actually have we don't have the objective function. Okay, once it will enter in the questions, you it will help you more to understand which is x and which one is y. Okay, so
Okay.
actually overall, whenever we do the mathematical modeling, okay, if you will see the first question, might be it will be hard for you, but once you do so much questions, okay, it will be very simple for you. You will see and you will immediately make the model. It will not be difficult because overall all LP problems are they are having the same information and same shape. Okay, you will immediately understand that which one is x, which one is y, and I have to take less than equal or greater than equal. All these things you will understand immediately. So first of all, once you get the question, you have to read 3 to 4 times. Okay, three to take time, much time to read the question, because solution will not take much time. You have to read the question many times in order to get the complete information. Then you will start the question. Once you have complete grip that, or you will understand it completely that this is x and this is y, then you have to start your solution. Okay, we go to the whiteboard and we will try solving these two inequalities. Okay, first inequality is 0.26x and plus 0.16y, and it is greater than equal to 120. And the second inequality was 0.03x plus 0.08y less than equal to 28. Okay. Now, first step is we will convert both the inequalities into equations. And the second one equals to 28. Okay, now we need 2 points from both the inequalities, and both inequalities are simple. You can take x and y intercepts from both the equations. You put x equal to 0, y will be
750.
750. Okay, if you put y 0, x will be
461.5.
461.5. Okay, no problem. Okay, no problem. If it is not a whole number, it's not a big deal. Um, okay, similarly, here we get 2 points. If I put x 0,
350.
350, and if I put y 0,
933.3.
933.33. Okay, no problem. Now I will go to the coordinate system. Here we have x-axis and here we have y, and here we have origin. And I will plot the okay, first of all, scale. Okay, scaling, you can see x is varying from 461.5, 993.5. Okay, so I will start it from 450 here. Okay, suppose 450 is here and 900 is here. Okay, for I took the scaling of 450 plus 450, 900. Okay, that's all. On the y-axis, if we see 350, 750, okay, let me take 250, 500, and here we have 750. Okay, now the first pair of the points, we have 0, 750, okay, here, and the other point is 461. 461 will be around here. Okay, it will be around here or more here, but because we have rough sketching, okay, it doesn't matter, but just we keep 461 to the right of 450, it's enough. Joining both the points. Okay, now we have to decide that the area is above the line or below the line.
Will be above.
Above.
Look at inequality. Okay, above, because if I put 0 0, it will not satisfy the inequality, so above. Okay, let me shade it green. Okay, so this is the area we have for the first inequality. Okay, now we come to the second one. Second one is 350. 350 will be around here. Here, and 933.3 will be to the right side here, around here. Okay, joining both the points with the help of a straight line. So this is the second one. Okay, this is the first inequality and this is the second one. Okay, area below or above?
Below.
Below. Okay, I will put 0 0. It will satisfy the inequality, so this means that the area is beneath the line. And if I shade it pink, so we will have here, you can see the dark, the common area. Okay, so the common area between both the inequalities is now visible. It will be here. This one here. So this small triangular shape is the feasible area we have for these two inequalities. So this is the solution, or you can say this is the feasible. Okay, this we say that this is the feasible area. Okay, its name is feasible area. Okay, or you can say this is the solution of inequality. Okay, now if you go back to the slides here, and now you can see the solution. I sketched first of all this one, then separately second one, and then if you combine both of them, okay, you should never do like that. Okay, we don't make the separate sketches. We do on the same sketch. Okay, it is just to show that if we combine both the areas together, means if we plot both of them together, we will get this triangular shape area. Okay, now, okay, with this example, we will enter in LP. Okay, but we will not start it today. I will just do this example. You need to understand this scenario that we have here in this example, because this example will lead us to the LP problems. Now, if you see the situation, we have the Sibdaria Citrus Company. They produce juices using the exotic fruits, including two made from hurma. Okay, hurma is the concentration fruit with the help of which they create two brands of juices. Anil, you can say this is X, and Emir, this is Y. Okay, they are producing two types of juices, Anil and Emir. Okay, fruit concentrate for these product is imported, and supply is erratic. This is flexible. Supply is flexible. No problem with there is no restriction on the supply. Siddhartha has 4,000 liters of concentration, Kurma concentration in their stock. Limit that in the stock level, the stock level is 4,000. Okay. The X brand anil consists of 8% concentrate, and Amir Y consists of 10% concentration of Kurma. Okay. Represents the fruit concentrate constraint as an inequality. Okay, we have to construct one inequality, okay, which must contain this type of shape. Okay, less than equal or greater than equal C. Okay, we have to construct by reading this whole situation. We have to construct this type of inequality. Uh, X and Y, we know that anil is X and there is Y. So how to construct the inequality? There is no keyword in this question. There is no keyword, so you have to use some logic. Yes.
Can I answer, doctor?
Yeah, go ahead,
First, 0.08 plus
Okay.
0.10 less than
Okay.
or equal 4,000 liters.
Okay, why you took less than? Why not greater than?
Because Sardinia, she has only 4,000 liters of forma. It's not
Yes,
logic,
exactly.
but
Exactly.
to be greater, it's not logic.
Yes, exactly. Actually, let me write what you have said. 8% X plus 10% Y, and we use less than equal to 4,000. And why we took less than equal? Because there is no keyword. Why we use less than? Because logically, if their total stock level is 4,000, how can we consume more than 4,000? Okay, so we cannot exceed 4,000. So this means we can use less than 4,000. Yes, we can use less than 4,000, but we cannot exceed 4,000. So in LP problems, whenever you see stock level, okay, so this means that this is restriction. You cannot consume more than that limit. Okay, so always whenever you see stock, okay, it always corresponds to less than equal sign. Okay, similarly, sometimes you will have restriction on labor. Okay, labor means you have this number of labor, so this means that you cannot use more than that number of labors. Similarly, sometimes you have limit on time. Okay, so such type of limits, if you see, this means less than equal. Okay, so this is your model, mathematical model. You can convert it into points by rewriting them into the form of without percentage. You will get the inequality. Okay, now you have to make the sketch. Okay, first of all, you will sketch the straight line, the equation. Okay, and then you will put 0 0 as the test point, and because 0 0 satisfies the inequality, so you will shade this area. Okay, this is sketching as we did in many problems. Okay, now we have another constraint on the same situation. On the same problem, we have another constraint, another inequality. Okay, read it. Siddhartha Citrus Company has a contractual obligation. They made a contract, okay, to produce 10,000 liters of anil X for an important customer. Model this constraint. They made a contract with some customer that they will produce 10,000 liter for him. So what will be the mathematical model for this?
Will be
Since
greater or equal?
Yeah,
Let's
because they have already contract. They can't produce less.
Yes, yes, exactly. They cannot produce less. So this means they can produce more than or equal to 10,000. Okay, so they cannot produce less because they have they have to fulfill the contract with they made with some customer. So they might have more customer than him. Okay, so to satisfy the demand for the other customers, they should produce more than 10,000. Or if they don't have any customer other than this one, so at least they have to produce 10,000. So this is the inequality we have. So this inequality is for just for x. Okay, now we have to make it sketch. So it's a vertical line, the vertical line at 10,000. So if we go back here, suppose here you have 10,000. Okay, if here you have 10,000, so the graph is a vertical line. Okay, and if you shade it, we will shade to the right side because it is greater than. So this is the area we have. Okay, so this side we will shade, and the common area will become the this smaller triangular area that you have here, here, and this one. So meeting these this area is the common area for now for two inequalities that we have. This is the that inequality, the new inequality we have, and combining both of them, we have this feasible area. Okay, we stop here. Okay, we stop here, and we next time when we start our lecture, we will start with the linear programming. Okay,